Okay, so let's discuss. This is the first DPP, right? First question. Let's discuss question number 1. Two positive ions, each carrying charge A, are separated by a distance d. If F is the force of repulsion between the ions, then the number of electrons missing from each ion will be. So positive charge means it must have lost electron. Negative charge means it will gain electron. So it has a charge of Q and Q, let us say Q and Q. So you know that Q can be written as N into E. That's all. The charge can be written as integral multiple of electronic charge where N is a integer. Now the force between them they have given and the distance between them is d. So force is k. K means what? 1 by 4 pi epsilon naught, right? K q1 q2 q square by distance square, right? That's also q is equal to n into e. You can first calculate, you can write that q is n into e, so it will become n square e square by t square, and from here you need to just calculate out n. So n square will come as f into 4 pi epsilon naught d square divided by e square, and you take under root, that is what it is. So n is equal to root under 4 pi epsilon naught f into d square by e square. What is the big thing in this? So some calculation mistake you have made. It is a very simple question, very basic level. Take care of this. Then the second is correct. Third is also correct. Fourth is correct. No, I think third is wrong. Third. Let us check the third question. A wooden block perform SHM on a frictionless surface with frequency. The block carries a charge plus Q on its surface. If now electric field is switched on, then the SHM of the block will be. Okay. So this question is related with SHM also. So there is a block here and this is a spring, let us say natural length, smooth surface. It has charge Q, mass M, and there is a electric field switched on. Switched on. So note that the electric field is a constant electric field, a uniform electric field. So as soon as you switch on, the charge will experience a force, and you know the force is equal to Q into E. Q into E, right? So charge is positive, assuming it is a positive charge plus Q they have given also. So it will experience suddenly it will experience a force in this direction. So it will compress, right? But it will start moving. Initial speed will be 0. It will start moving from that position, and it will compress. Further, it will compress, and there will be a position where spring force will equal to this uh, electrostatic force. Okay, so there will be a position, let us say here. I will draw the diagram again here. So this spring has now got compressed. Spring got compressed. So originally this was at this position. So from this position it got compressed. Some distance x naught it got compressed. And here this force which is acting F is equal to spring force. Spring force is k x naught. The spring force is k into elongation. So at this place it is, let us say, equilibrium has achieved. Equilibrium means what? Forces are balanced. Forces are balanced. But this does not mean the body will stop. Body have speed. Like in SHM, body has maximum speed at equilibrium position and it goes to the other extreme. So right now this is what? This is like a equilibrium position, mean position. This is like a initial position is like a extreme position, right? So this is like a extreme position, this is extreme position, and this is the mean position. So it will not stop here because it will gain some speed here. So it will go the same distance that side, correct? It will go to the same distance that side, same distance this side it will go, and then it will stop because then it will reach its extreme position. So that will be its another extreme position, another extreme position. So this oscillation, always takes place about a mean position and between two extreme positions. So what happens is that the mean position is now here. Previously the mean position was here. Suppose you have not applied any force, electric field or electric force, then what happen if you compress it and leave it, this itself will be the mean position, and if you compress it here and release, so that will be the extreme position. So what happens is the mean position changes, right? Mean position changes. And what is the mean position? If they ask what is the mean position or what is the amplitude, so from the original position here, this distance, so here forces you have to balance. The force, this electrostatic force is equal to spring force kx naught, and this is q into E, so kx naught. So that amplitude is qe by k. This is what it is. So the mean position has shifted, but the frequency have not changed. Note that frequency of SHM omega, root under k by m, root under k by m, this does not change, right? This does not change. This depends only on spring constant and mass of the block, right? Clear? Yes. But note here, now I will tell you very important thing, why the this is happening, because the applied force is a constant force. Whenever the applied force is a constant force, then the same situation will happen, right? Whenever the applied force in a spring block system, the applied force is a constant force, the mean position changes, right? The mean position changes, equilibrium position changes, right? But what happens, the frequency does not change. So this is a point we can note, that whenever, if an external force which is constant, external force which is constant is applied on the spring block system, on the spring block system, the frequency does not change. The frequency does not change, but the mean position changes, but the mean position changes. So whenever you apply a external force on the block which is connected with a spring, and if that external force is a constant force, then assume that frequency will not change, only mean position will shift. But now take example of the variable force. Very good question, one student asked in the class. It's a very good question. Okay, take this. That is why, because if student will ask question, then only we also learn. It is so simple. Okay, suppose this is a charge and this is a mass, and there is a spring, and this is a charge and it is a mass, and this block is fixed. This block is a fixed block. Okay, this block is a fixed block. Right now what happens, that initially there was no charge on the body. Initially the bodies were like in without any charge. Okay, the bodies was not having any charge. So anyway, one was fixed only. Now one was like fixed only, this can only move. The charge was not there, only what masses was there. So if only mass was there, and if you move this side, compress this side, or elongate this side and leave it, it will oscillate. And this was supposed to be the mean position, because spring is not elongated. Okay, charge was not there. Initially charge was not there. You can remove the charge if you want. Initially only mass was there. Okay, so what happens is that here mass is m, here also same mass, but this is fixed, it cannot move, right? and if you give this side this, so this was the mean position, this was the mean position. Why? Because here the spring has no elongation, which is natural length, okay, and here force is 0. If you elongate or if you compress and leave it, then SHM will be there, and wherever you compress and leave, that will be the equilibrium position. Suppose you have elongated x distance and left it, so that x distance which you have elongated initially, that is the amplitude, okay. So with that it will keep on moving. But now the question is, charge is given on both of them. Now you think what happened, this is fixed, but it has got charge also, but this is fixed, okay, this is fixed, but because you have given charge and this is free to move, so it will elongate first of all, right? Right, if you leave it, it will elongate, correct? Why it will elongate? Because of repulsion, it cannot remain here, because of repulsion it will happen. So repulsion will happen and now it will come here. So it will be a different equilibrium position, and it is said in the question that, in the question what is said, that this was the original length of this spring. Now the elongation that has happened is also equal to L. Elongation, this is elongation that has happened, and after coming to this elongation, this becomes an equilibrium position. So if that is equilibrium position, this is now the new equilibrium or new mean position it is. This is the mean position, okay. So now the question is, if you now disturb from its mean position, what will be the frequency? Will the frequency remain same? And I told you, yes, it may be remain same. But it is not true, because the reason is that the electrostatic force between these two charges are not a constant force, because it depends on distance. If you change the distance, now if you compress from equilibrium position, if you disturb now, then what happens is that the force, external force due to charges, electrostatic force that will act is a variable force. So here frequency will also change. That was a new thing to learn about it. Okay, so how to calculate? Now let us see that. In the book it was given some energy method which may be complicated, but then I solved it using simple fundamental method. How? Suppose you disturb it from this mean position. Let us say you have disturbed it here. This is the disturbance given. Okay, this is, and they have told in the question that disturbance is very small, otherwise it will not be as such. So you are giving a very small displacement. So now from this position, charge mass, what will be this distance? Already this is 12 plus x, so this distance will be 12 plus x, okay. 12 plus x will be total distance, okay. But what is the total elongation? Elongation you have to count from this position. So this is already L, right, and this is x. So elongation in the spring is L plus x. Okay, so note here that at this position a new equilibrium has achieved. New equilibrium means what? New equilibrium means this electrostatic force and this spring force are balancing. So spring force which is acting as K into elongation, elongation is L, and electrostatic force is K Q1 Q2 by distance. Distance is 2L whole square, so 4L square. So first we should note that K is different, okay. So let us make sure that you write this as Ks. Ks means spring constant, okay. Ks is spring constant. So this K and that K should not be confused. This K is 1 by 4 pi epsilon naught. So this spring constant or this force and this force are balanced because this is new equilibrium position. K Q1 Q2 by R square. R distance is 12. So 12 whole square. So this is balanced. So let us write this equation. Ks into L is Kq square by 4L square. Okay, so you have got this equation. So let us keep this equation. We can use this equation. Now you have disturbed it from here. So what will be spring force now? Spring force will be Ks into elongation. Elongation is L plus x. And Electrostatic force of repulsion is K Q square by distance. Distance is becoming 12 plus x. 12 plus x whole square. And because it is going to be SHM, there must be a net force towards the equilibrium position. So force must be this side. Okay. Net force. That means this spring force will be larger than that force. Let us try to calculate that. So now the net force will be, and we are going to write a minus sign to show that total force is towards the mean position. So this force minus that force. So spring force KSL plus x minus this force KQ square by 2L plus x the whole square. Now try to simplify this. Try to simplify this. You can open this Ks into L plus Ks into x minus KQ square. KQ square you can substitute. Okay, from this equation you will see that KQ square becomes spring constant Ks L into 4L square. So Ks into 4L cube it becomes. Okay, so use this and substitute it here. So KQ square I am going to substitute as Ks into 4L cube divided by, and here 2L I will take common out of this. So 2L square will become 4L square, and this will become 1 plus x by 2L whole square. Then we are going to substitute and simplify this. So minus Ks into L plus Ks into x minus, here 4L square will get cancelled, so Ks into L come, and this can be written as 1 plus x by 12 power minus 2. Now we can apply binomial expansion. Binomial expansion, you know, apply binomial expansion. Minus Ks into L plus Ks into x minus Ks into L. 1 plus this factor x is very small, so x by 2L, that factor is going to be very smaller than 1. So you can apply the binomial expansion. So 1, this will become minus 2 times x by 2L. So that's all. This 2 will get cancelled. Now open the bracket. So minus KSL plus KSX minus KSL minus plus KSX. So what do you find from here? You find simply that this term KSL got cancelled, and you got net force as minus 2Ks into x. Now force is mass into acceleration, so mass into acceleration is minus 2Ks into x. And once you got this, you can get acceleration equal to minus 2Ks by m times x. So this factor, now you know what is this factor. Tell me what will be this factor. What is this? Yes. In SHM, what is that? In simple harmonic motion, what is acceleration? Yes, Chris. Yes, Chhatres, SHM. You remember what is SHM acceleration formula? Huh? How? SHM formula, you know, na, acceleration equal to minus omega square x. Yes. Then, so that term is omega square minus omega square, and this term is omega square. So omega square is 2 spring constant by mass, and omega is equal to root times 2 Ks by mass. And if you want frequency, then frequency omega is 2 pi into frequency. Omega is 2 pi into frequency. So from here, frequency, linear frequency also you can calculate 1 by 2 pi root under 2 spring constant by mass. Right? Normally in SHM, what is the formula for omega? Omega is root under K by m. spring constant by mass, and frequency is 1 by 2 pi omega root under ks by mass. This is called natural frequency. This is called natural frequency. Natural frequency. So this is the natural frequency. Now this frequency is not equal to natural frequency. The frequency has changed. This was the system when there was no charge, no electrostatic forces was acting, right? Or a constant force was acting as in the question given in the paper, right? So that in that case frequency does not change. But because if you are putting charges, force between charges, which is a variable force which changes with distance, that is why frequency changes. Are you understanding this? Clear? So you see this question which was given in the paper was not a tough question, which was a easy question. Now this question which I am given, it is a tough question. Not everybody can solve it. But now you will know if any type of questions are coming, what is the concept involved. Concept is that if the force is a variable force, then frequency will change and mean position will also change. But if the constant force is applied like Q into E, if electric field is uniform, in that case mean position will only change but frequency will not change, right? So this will ask in adjacent region questions, they can ask very fundamental type of question in need they can ask. Okay, we should be clear about that. Let us move next. So after this next question is correct, then question number 5 is also unattempted. 5 was unattempted. Okay, let's see. So question number 5 is what? 5 is same type of question. Okay, this is a spring, so position is going to change. So initially this is a block of charge q, mass m, right, and a field, electric field is switched on. So as soon as you switch on electric field, the mean position will change. So mean position will now change like this. So I told this become x naught, and in this mean position, this is spring force kx naught balances this q into E, and this is the mean position, this is the extreme position, this is the extreme position, and there will be another extreme position this side. So this will be another extreme position. So this distance is also x naught, right? So this distance x naught are equal. This is called amplitude of oscillation. So if you release the body from here, it will go and it will have maximum speed at mean position, and it will go to the other extreme where again its speed will become 0, and then it will return back. Okay, so they are asking the maximum compression. So when you leave it, maximum elongation or maximum compression. Okay, this charge is negative, I think the question charge is negative, so it will go this side. That's all, right? Charge will go this side. That's all. That means you can say that it is started from here. Let us keep it like this. You can say that this electric field was switched on initially time 0, it was here, right? And charge was negative charge. So negative charge was minus q charge was there. So you know the force is going to act opposite. So QE force will act opposite, right? So here the force is going to act in this way. So you need to consider this. Huh? So at this position, because of negative charge, force acts opposite of field. So QE balances Kx naught. So mean position is this way. This will act. So as soon as you leave it, this will come here, equilibrium. It will go here, then come back here, then go here, then come back. Then oscillation will keep on happening like this, right? This is how oscillation will happen. Are you clear about this? Huh? So what is the maximum compression? So from here to here, this is first compression to attain equilibrium, then it will go other side. So this is also compression. So this is this and this. So x naught plus x naught, 2x naught. So maximum compression is equal to 2x naught. And what is x naught? Because it is balancing here, so QE and Kx naught become equal. So QE and Kx naught become equal. So x naught is QE by K. So that means 2 QE by K. This is what it is. Okay, so third option is correct. Okay, let us go to the next question. Fourth question. Um, Fourth is correct. Fourth you have done correct. Fifth we discussed. Sixth is also mistake. What is the problem in six? To sort electric dipole of moment, okay, shown at the corner, what is the ratio of magnitude of field at? See, this type of things we discussed also. Electric dipole moment is P here, and this dipole moment is P. So if you remember, we have discussed that if we have to find out at any point, how do we calculate? This is point 2, okay, and this is the midpoint. It is joining here. This is like a square, so this is a square, this is a square. Side of the square is corners of a square. They have not given side. Let us say side is a. So do you remember about this dipole, or did you forget it? Yes. How do we solve some type of question? Ratio of electric field at 2 points O and A. At this point O and this point A, they are asking electric field here and here. How do we calculate electric field due to dipole? In dipole, you remember two important results: electric field at equatorial, electric field at axial. Do you remember that? Not remember? Forgotten? So this is minus q charge, this is plus q charge, and they are separated by distance a. This is the midpoint 2. Remember this, okay? So are you able to see this visible clearly? Okay. So what happens is that this is called axis of the dipole. So any point here if you want, and this is the dipole vector direction from negative charge to positive charge. So this direction is the direction of P factor. So here at this point field is also in this direction, axial field. Axial field formula for short dipole is 2k P vector, 2k P vector by r cube. And equatorial means the perpendicular bisector. See, you need to keep on revising things, then only you will be able to remember that equatorial is opposite of this. So equatorial field vector is minus k P vector by r cube. This is for short dipole formulas. You have to write and practice it. Okay, then now they are asking question that what is the field here and here ratio. For first calculate field here. So to calculate field here, you should know that this point is a equatorial point for this, because this is perpendicular bisector. Similarly, this line is also perpendicular bisector on this. So that means here, due to this one, it will go like this equatorial, and due to that one, it will come here as equatorial. So the resultant or net will be root under 2 equatorial, because the angle is 90 degree. Root under this square plus this square is root 2 into this. So you will get this, right? You will get this. And what is this value? Let us solve it. So this is root 2 into equatorial. Equatorial formula is what? Magnitude will write kp by r cube. So k is a constant, p is that p factor, p by r cube. R cube means distance. Distance is a here, a cube. So this is this resultant. Okay. Now what about here? Note that this angle is 45 degree, because it is a square, right? 45 degree. So what you need to do is you need to resolve it components in this direction. In this direction, its component is p by root 2, p cos 45 degree, and this direction also p by root 2. Similarly, here also this component is p by root 2, and this component is p by root 2. Okay, now if you see that for this point, for this dipole moment, this point is a axial point like this. If dipole moment is like this point is like the axial point. So same thing is happening for this p by root 2 dipole moment. This is the axial point. So here the electric field should come like this. E axial will come. Okay. Similarly, due to this one, due to this one, the axial field will come this way, which will be E axial. So that means what? That simply means that this E axial and this E axial are equal and opposite, because the distances are also equal, and right, this field are opposite. So they are going to cancel out, right? They are going to cancel out. So what is then remaining? Then you have to consider for this case, this p by root 2. For this p by root 2, this p by root 2, here this point is a equatorial point and it will come in this direction, equatorial. Similarly for this one, this is again equatorial, so again this will come equatorial. So two equatorial points will come, so resultant field there will be 2 times equatorial. 2 times, but remember, you need to know the distance here. This distance you have to first calculate. How much is this distance? This distance, because this is diagonal, right? This is diagonal. Diagonal is root 2 into side, so root 2a, and half of this, so a by root 2. Note that this distance is a by root 2 and this is also a by root 2. So when you are using the equatorial formula, 2 times k p by r cube. R means this one, a by root 2 whole cube, a by root 2 whole cube. So how much it will become? Check out that root 2 root 2 root 2, 3 times it will come in the numerator. So root 2 root 2 root 2, root 2 4, 4 into 2 8, 8 root 2 will come, 8 root 2 kp by a cube, right? And this was root 2 kp by a cube, correct? Am I correct? Ah. Okay. Let me check any calculation mistake I made. Kp. Oh, Kp. Kp by, but what is P? P is P by root 2. Note that here due to this component we are taking, so this P is P by root 2. P by root 2 is also there here. P by root 2 means root 2 factor should come here. Okay, right. That means what? This means it is 8 kp by a cube. Okay. Now what they are asking, that they are asking the ratios of O and P. So here and here ratio. Now let us calculate. So the field at this point, which is 8 kp by a cube, divided by root 2 kp by a cube. So here kp by a cube, kp by a cube gone. So 8 by root 2. 8 by root 2 is what? Cancel out. This become 2 root 2. Correct? 2 root 2 it will become, because this is 4 into 2. No. 2 root 2 or 4 root 2? What it will be? 4 root 2 should come now. Check out any mistake has happened, because the answer was given as 2 root 2. Where is the mistake? Root 2 root 2 2. 2 root 2 comes. 2 root 2. Root 2 root 2 root 2. 2 root 2. 2 to 4 root 2. 4 root 2 it is, I think. Yes, this is 4 root 2. This is 4 root 2. Okay, this is 4 root 2. So this term is 4 here. 4 kp by a cube. Okay, so this factor is 4 here. 4 kp by a cube. Okay, so from here this ratio is 4 by root 2, then it comes to root 2. Definitely this question was a difficult question, because this requires calculation not only at this part but here, where it requires resolution and then doing calculation. You cannot immediately do it. It is a time taking. So some questions are difficult, but we should know the technique. It may take some time. If it is difficult question, we can skip it and we can do at the last after completing easy questions. Okay, but negative we should not do. So you see where you have made negative, okay, where you have made mistakes, you should correct that. Okay, next. Question number 7 also is mistake. What about question number 7? Where is the mistake? 7 is there is a plates are given. This is positive charges and this is negative charges. Right, in uniform field is constant and the field is given as 8m by E. Field is given like this. Created between two plates. Okay, one length is 1 meter as shown. Electron interfered symmetrically between the plate with a speed of 2. Symmetrically means what? Electron is entering exactly in between. This is a electron, negative charge with a speed of 2 meter per second. It is going to enter. Which direction field is? Field is from positive to negative. This is the direction of field vector, right? So electron is a negative charge. Which direction it will get force? Will the electron move opposite of field or towards the field? Yes. Yes, Satresh. Does the electron move in the direction of field or opposite of the field? Opposite. It will get a force opposite because it's a negative charge. So because this is a negative charge, it field is downward, it will experience a force upward. Q into E. That is the force. Okay. What about the weight mg should we consider or not consider? They have not given any criteria for mass, so let us not consider mass. This is the only force acting, and because of that force in this direction, note that there is no force, so no acceleration along x-axis. Acceleration along y-axis will be there, which is force by mass, so QE by m. QE by m is acceleration, so acceleration along y-axis will be QE by m. Q means charge, charge is E, so EE by m. EE by m, EE by m is 8 here, so 8 meter per second. 8 meter per second square is the acceleration in the upward direction. Okay. Now the question is angle acid. So as this is going to come out here, it will be coming out in this direction velocity. So the direction of velocity will make some angle theta. This angle they are asking. So note that if you can calculate velocity along x direction, velocity along y direction, then tan theta can be easily calculated as Vy by Vx. And velocity along x direction will not change because acceleration is not there. Okay, along the x-axis there is no acceleration. So this velocity Vx will remain as 2 only. Vy you have to calculate, so V equal to u plus at. You can apply u in that direction is 0. In this direction initially there is no speed because it was projected horizontally. So V equal to u plus at, acceleration along y direction, time. But time, how do you calculate time? So when it is going to come out in this direction, it is moving horizontally. So how much time it will take? Time taken is distance by speed in the horizontal direction. X by speed in the horizontal direction. Distance by speed. So x distance is 1 meter. Speed along this is 2. So 1 by 2 is the time. So substitute here. Ay is 8 and 1 by 2. That means 4. So you got Vx, Vy, right? So substitute tan theta, Vy is 4, Vx is 2, that means 2. So that means theta is tan inverse of 2. That's all. Clear? Yes. Are you clear about this? Okay, so note that here inside the field, right? Inside the field, it is going a trajectory. This is a trajectory which is a parabola, just like projectile motion. You have studied projectile motion, right? When you throw it like this, it goes like this. Why it is going like this? Because in the horizontal direction there is no acceleration, and along the vertical direction there is gravity downward, minus g is right. Okay, same thing is here. In the horizontal direction there is no acceleration, in vertical direction only thing it is upward. So that's why projectile is going like this within the field, but once it is coming out of field there is no force. Of course here you are neglecting gravity, but in real life gravity can also be considered. Okay, right. Then next, question number 8 is also mistake. Question number 8. Question number 8. Three charged particles are placed on circumference. So on the circumference, three charged particles are kept. So where are these charged particles? One is charged particle C, one is charged particle A, right? Q by 3. This is also Q by 3. This is exactly opposite of this. B, this is also Q by 3. Okay, all these charged particles are kept here. Three charged particles at circumference, radius is charge. The magnitude of force between charges C and B. They are asking force between C and B. Between C and B here. That means you have to only focus that. Okay, force between C and B, and they have given this angle as 60 degree. So first of all, you need to find out distance between this C and B. Once you got distance, then game is over, because distance only you are supposed to know, right? Because charges are given, product of charges you can do, and distance square you have to do. Distance you have to calculate. So note that this is the radius r, this is the radius r, and this is 60 degree. So this will become 120 degree, and if you drop perpendicular from here, so it bisects here, right? So this becomes 60 degree, this becomes 120, and this will become 30 degree. So that's also, you can use this distance. Let us say this distance is x, it is like the chord length. So this total distance which you want to calculate is 2x. So how much is x? X will be r cos 30. R cos 30. Cos 30 is what? Root 3 by 2, 2 get cancelled, root 3r. This is the distance r which you want to use in the force formula. That's all over. So force between these two charges is k q by 3 into q by 3, product of charge, divided by distance r square. So now you solve it. K q square by 9. R square means r is how much? Root 3r. So root 3 square is 3r square. So this become k q square by 27 r square. This type of simple question you should not make mistake, because there is not much complexities here. Complexity will be there, then it is like a one dipole question, complexity was there. But by practice solving different type of model of question, you will get all these ideas. Okay, then let's go next. Ninth question was correct. Right, 10th question, last question. Last question was also correct. Done. So did you get this where your mistake was there? So tell me, how will you improve? How are you going to planning to improve? Daily, how many questions are you practicing? Hmm. Daily are you doing, or alternative are you doing? Daily are you solving, or alternatively you are doing? No, 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 not sometime. You need to make a like a daily routine, schedule, that you have to invest that much time, more than 20 or 25 questions you have to solve. See, I am getting this, putting this DPP for half an hour, 30 minutes. In 30 minutes, target is like 10 questions. If you can solve 10, but these 10 questions are little difficult side, not very easy questions. Okay, sometimes few questions may be easier. But first is this target. I am not saying immediately you jump to solving so many questions. First you solve 10 questions, and when your efficiency will improve 100%, that yes, you can solve 10 questions in 30 minutes, then I will give more questions in 30 minutes. Okay. So first your target is 10 questions, without any mistake in 30 minutes you can solve. Okay. Then gradually I will improve more number of questions, and then neat model paper also I will make 45 questions in 1 hour. Okay. Okay. So target it like this. So your exam portion is completed or anything is pending from our side? Check that. In your school, the syllabus that you posted, now what about that? Did we complete or anything remaining? Today you had your exam. Over, how much? How was your paper? Moderate. How much are you getting in that paper? 40. That means 40 is correct. Huh? No means out of total 180 in physics you are saying, right? Physics out of 180, right? Out of 120. Hmm. It is a neat model paper na in your school. Okay, okay. So 1 minute. I got your module that charges and field was there. All the topics was there, right? Charges and field was there supposed to be. So finite rod, circular arc, disk, motion of charges, particle, and okay. Hmm. Oh, so number of questions are 30 only, yeah? Oh, so that means physics is objective questions. Why 30 only? Your model paper is not like neat paper, huh? Oh, okay, okay. That means they are keeping separate. So out of this 120, how many marks are you getting in this? Why? It is like one third only. Why? Oh, careless. No. Yeah, you're practicing, na. You should not do careless mistakes. Hmm. Now 1 year is over now. That whatever careless mistake you made, that's over. Now you have to improve. Now you should not make any calculation mistake. Okay, first calculation mistake should not happen, and like practice should be proper. Like if 120 marks question, that means 30 questions are there. So this 30 question at least you can definitely do more than 20 questions, 25 questions like that. Definitely you can do. You have to target it. So how much time are you taking? Like are they giving separate papers or together all the papers? Like this today was only okay, separate test they are taking, huh? Like physics is separate, other subjects are separate, like that they are taking. And all these are objective questions only, na? Okay. How much time they give? 1 hour. Hmm. Oh yeah, but that's okay. For 1 hour means 30 questions, but in NEET you have 45 questions, right? And how much time you have in NEET? Huh? Pre- Previously it was more, na? They have reduced the time, right? Yes. I think previously it was little more. Maybe due to COVID, it was there, but they have removed that thing. Okay, so now you have in 1 hour you have to solve 45 questions. How do you plan to do that? So what do you want? Do you want more number of questions should I give you, which you can solve in 1 hour? So will you give neat model practice? You will write online questions. How much time can you give? Because according to that time, I will make the paper. Hmm? Huh? 45 minutes. How much time you can sit and write like exam type? You tell me. Okay. Okay, let's first do for these 30 minutes. Okay. 30 minutes I will increase number of questions like for 30 minutes I can keep like 15 questions like that. That means on an average you can solve 2 minutes one question. Okay, right now I am giving average 3 minutes. Okay, 10 questions right now I am giving, so that you may take little, if you are slow little bit you may take more time, but 10 questions you should do correctly. 30 minutes is sufficient for 10 questions, right? Okay, gradually I will increase the number to 15 question and then 20 question, like that I will do afterwards. But first you improve your accuracy also, because 3 minutes is more than sufficient. You need to practice more. Okay. So did you solve the worksheet 2 and worksheet 3? When you will solve it? Okay, do that. Okay, once you finish those things, then you can attempt your second test. Okay. And neat model papers also I will be putting. I will especially neat I will prepare for you. Okay, then we will see that. Fine, then we'll see next class. Okay. Yeah, thank you. Bye bye.